All right, so get this. What if instead of like rockets and all that, we could move through space by like nudging, just slightly nudging the very fabric of reality?
Whoa.
That's what we're looking at today, right? This whole idea of using a frequency-based model of force for propulsion.
Yeah. Yeah.
And we've got some really wild material to dig into that explores, how understanding and manipulating forces through their frequencies, could completely change how we think about, well, everything.
It really could.
So today, our mission, should we choose to accept it, is to figure out how this might actually work. Like, how do you actually build something that can do this?
Right.
And then we've got the whole, the concept of messing with gravity, but just in a tiny little spot.
Localized gravity modification.
Yeah.
Which is, yeah, that's a huge one.
And of course, the big question, when are we going to see some of this stuff actually happen?
When can we get our hands on it? Yeah.
Exactly. So let's get into it.
Okay, so I think what's really fascinating here is the fundamental shift in perspective that this model brings. We tend to think about forces as just these things acting on objects, pushing or pulling.
Right, just like basic physics.
Yeah, exactly. But this model suggests that these forces, they actually come from these underlying oscillations, these frequencies, almost like a vibration at the heart of everything.
Okay, so it's not just like a straightforward push or pull. There's a deeper level to it.
Exactly, yeah. And when you apply this to something like the Casimir effect, that tiny, tiny force that you get between two surfaces that are super close together, you start to get some really interesting ideas.
Yeah.
Like imagine if we could engineer materials to resonate, to vibrate in tune with specific frequencies in the quantum vacuum.
The quantum what now?
The quantum vacuum is basically this background hum of energy that's always there, even in empty space.
Even in empty space, there's energy there.
It's wild, right?
Yeah.
But according to quantum physics, it's teeming with this energy, even if we can't see it. And the idea is if we look at this background energy as a collection of different frequencies, that we might be able to create materials that can actually interact with those specific frequencies.
So basically like tuning into a specific radio wave, but with the fabric of reality.
Exactly. And by tuning in just right, we could actually generate a controllable thrust. We could use these frequencies to push things around.
So it's like we're riding a wave of reality, basically.
In a way, yeah.
Okay, so hold on. We're not talking about just any old materials here, right?
Right.
What kind of stuff would you even need to build something that could, interact with the quantum vacuum?
You're right. This isn't like building with wood and nails. You need some pretty special stuff. We're talking about metamaterials. These are structures that are engineered on a scale smaller than the wavelength of light.
Smaller than light. That's tiny.
Incredibly tiny. And the way they're built, it's like, think of them as incredibly intricate filters designed to interact with and shape these quantum frequencies in a very specific way. Like, imagine a net that only catches fish of a certain size. That's kind of what metamaterials do, but with these quantum frequencies.
So we need to like weave the fabric of reality into a net that can catch these frequencies.
That's a really cool way to put it, yeah. And this ability to fine-tune that interaction at such a fundamental level, that's what's key to making this whole thing work.
Okay, so that's the Casimir effect stuff, right? But then there's the really wild part, this idea of localized gravity modification. That sounds like something straight out of science fiction.
Oh, it definitely does. But some pretty serious theories suggest that gravity itself might actually be an emergent phenomenon, something that arises from even deeper quantum fields.
Okay, hold on, slow down. You're losing me a little. What does that even mean, that gravity is like emerging from something else?
So we normally think of gravity as this force of attraction between objects with mass, right? But imagine that this force isn't really fundamental, that it's actually the result of these deeper quantum fields interacting in a certain way.
Okay, so it's like gravity is the shadow of something else, something deeper going on.
Yeah, that's a good way to think about it. And the idea here is that by creating specific interference patterns, like ripples, within these underlying frequency fields, we might actually be able to change the curvature of space-time, which is what we perceive as gravity, just in a small area.
So it's like we're making a dent in the fabric of space-time.
Sort of, yeah.
Yeah.
It's almost like how sound waves can cancel each other out, If we could generate the right gravity waves, so to speak, at the right frequencies, maybe we could weaken or even strengthen the gravitational pull in a specific spot.
Whoa, okay. So let's bring this back down to Earth for a second. In the near future, let's say the next 5 years, what are we realistically looking at here? And then further out, maybe 10 to 20 years. Small steps or giant leaps for mankind?
Okay, so in the next 5 years, I think we're more likely to see advancements in harnessing the Casimir effect for very precise, small-scale applications. Things like fine adjustments for satellites or propulsion for tiny robots.
So, like super precise movements, but on a tiny scale.
Exactly. Now, the longer-term goal of localized gravity modification, that's a whole different beast. We're talking about needing some major breakthroughs in our understanding of physics and being able to control energy on a level that we can't even imagine right now.
So, gravity control is still a ways off.
I'd say so, yeah. But who knows what the future holds?
True, true. The material we're looking at also keeps bringing up these AI control systems. Why are they so important in all of this?
Well, think about it. If you're trying to create stable thrust by orchestrating these incredibly subtle interactions between frequencies and fields, you're going to need something incredibly smart to manage all that. It's just way too complex for humans to handle directly.
So it's like the conductor of the reality orchestra.
Yeah, that's a good analogy. And not just any conductor. We're talking about highly sophisticated AI algorithms that can learn and adapt in real time.
That's some next level stuff.
It is. They'd need to constantly monitor the quantum environment, which is always fluctuating, and make adjustments to maintain stable and efficient propulsion. It's a huge challenge.
Absolutely. Okay, so now for the big question that always comes up with these futuristic ideas, energy. Manipulating the fundamental forces of the universe. That can't be cheap, right?
You're hitting the nail on the head. That's one of the biggest challenges we face. While the theory suggests that this kind of propulsion could be incredibly efficient, actually generating and focusing the necessary energy at the right frequencies, that's a whole other story. We're talking an immense amount of power.
So while we might figure out how to do it, actually powering it up is a whole other problem.
Exactly. And we still have a lot to learn about the energy dynamics involved in these interactions. Like how much energy do we really need and where does it all go? These are big questions.
For sure. And of course, none of this matters if we can't actually prove it works, right? I mean, theoretical models are great, but seeing is believing.
Absolutely. That's why laboratory validation is so crucial. We need to design experiments that can isolate and accurately measure these subtle forces.
So we can actually see them in action.
Precisely. We need to be able to see them, measure them, and confirm that we can actually control them. That's the only way to turn these theories into reality.
Well, there you have it. We've taken a deep dive into a truly revolutionary and maybe even a little bit crazy approach to propulsion, manipulating fundamental forces through their underlying frequencies, from the Casimir effect to the mind-bending idea of localized gravity modification.
It's a field with a lot of potential, that's for sure. Some near-term possibilities and some pretty ambitious long-term visions.
So here's something to think about. What if we really do crack the code of these fundamental frequencies, these vibrations that underpin reality? How would that change not just how we travel through space, but our entire understanding of the universe? What other secrets are hidden in these cosmic vibrations? Just something to ponder.
Yeah, that's something to think about.
All right, until next time.